Hey everyone, welcome to the technical takeoff session for Windows Update Troubleshooting. My name is Mustafa and I'm a product manager on the Windows team, and I'm joined with my colleague Akash. We have heard your pain points and requests regarding Windows Update Troubleshooting. Today's session will cover how you can utilize reporting to find and fix your issues, and if you still can't figure out the issue, we will cover how to get your hands dirty with logs. Today's agenda for reporting is updates plus device alerts, log analytics, and top update issues. For troubleshooting with logs, we'll be covering a demo on how to collect logs, the high level architecture, where the problem exists, what the end user is seeing, and how can you fix that issue. To start off with reporting, I'm going to be handing off to my wonderful colleague Akash.
My name is Akash Malhotra, and I'm a product manager here on the Windows Service and Delivery team as well. I primarily work on Windows Update for Business reports. I want to start by diving into our update reporting, which should be the first place to start when it comes to managing your patch compliance. Our reporting solutions offer comprehensive information that can help you monitor your updates and see where they're actually failing. So let's start with some alerts we currently have in reporting. Whether you're using Windows Update for Business reports or you're an Autopatch customer using reporting within Intune, we have a set list of alerts which are triggered at an update and device level. There are two kinds of alerts: update alerts and device alerts. Update alerts are triggered during the update process when something goes wrong. For example, if the client is not able to download the update package due to a network error, in that case, we throw an error code with a description and a recommendation on how to take action. Same with device alerts, which are activated because of an issue that is device specific. So for example, if a device is missing multiple security updates, then we'll throw recommendations that can help you resolve that issue. The recommendations should be used as a first level triage to help you self-serve. We also have warning alerts, which are more preemptive alerts that can help you be more proactive. For example, if a device is about to reach end of service within 6 months, we alert you on this. And so you can actually act sooner than later to make sure that all your devices are up to date, so you don't wait till the last minute. The reports are a great visual way to see what alerts you should focus on, and it should be your first point to start off with. Now, if you want to dive deep into the data, you can use log analytics to query alerts in your environment. You can use the update alert table to get the top active alerts. You can see how long they've been active for. You can also export all the affected devices and use PowerShell to take some sort of action. Sometimes devices can't update because they're unable to scan the Windows Update service. And so we have a field in the data schema called last WU scan time, which tells you the last time the client scanned Windows Update. An empty field could mean that it hasn't scanned in over 28 days or it's not online, indicating that the client is unable to connect. We also have fields like the client state, which tells you where the device is stuck in the update process. Using alerts with a combination of update states, you'll get an understanding of where your devices are. Now, let's talk about some of the most common update problems we see in the enterprise space. Firstly, devices are not just active enough. If a device is not online and connected to the internet, it'll simply not scan Windows updates. When tracking your patch compliance, it's advised to filter out old stale devices which are never online so that you get an accurate representation of your updated devices in your ecosystem. Secondly, not scanning Windows Update. There can be multiple reasons the device is unable to scan the Windows Update service. It's possible that telemetry is not being sent, in which case you'd have to ensure that clients are properly configured to send data to Microsoft. We recommend sending it to the full optional telemetry diagnostic setting to provide more insights. It's good to check if all the Windows services are running. Sometimes we see firewalls and VPNs block endpoints, which in effect block the device from connecting to the server. It's also good to check the logs for any errors. We'll show you later on how to do so in the presentation, but this is something you should look out for as well. Indicators that something went wrong in the logs. Lastly, simply retry the scan. Sometimes we notice that a scan failed for some reason, and retrying is a good way to check if it's a one-time failure. In a lot of cases, a device just requires a restart. So check your deadline policies and ensure that they're configured properly. If you're using reports, we tell you the device is in a restart state so you can target those devices specifically. And lastly, some issues are just transient. There's nothing you can do about them. They will come and go and most likely disappear within time. Safeguards are a good example of these. Safeguards preview a device with known compatibility issues from being offered, so we don't offer the update to your device. This is something that Microsoft owns and we fix. Now let's dive into how logging works and back to Mustafa.
Thank you so much, Akash. After going through reporting, you get your hands dirty with logs. Logs are so important as they allow you to have a sneak peek into the internal mechanics of your machine. And to start off, we must open logs. And to do that, we'll share a brief demo video which utilizes Woo Copylog External. Note, this process is something we do at Microsoft, and not all tools are publicly available just yet. As the demo video shows, we use Woo Copylog External, which downloads logs in the temporary folder. From here, we copy our logs into the folder we want to store them in. They are being stored in a temporary file where we can view them later, and they'll be compressed accordingly. As you can see on the screen, we cd into the temporary file, then we run copy logs. Note, compressing times can vary based on the size of the log files. After getting the file path, we post it in File Explorer. Next, we unzip the logs by extracting them from the compressed format. After this, we'll go to the USO folder, and within that folder, we'll be decoding our logs, which I'll be showing just shortly. We go to the USO folder and we decode the logs by running decode wooetl. Again, times can vary based on the size of your logs, and this can vary from machine to machine. Once completed, we can access the text of our files in our logs, which in this case will be the Mo USO code worker logs. And yes, I know we rushed through this quickly, but we will share a comprehensive guide in a blog for this, and I'm so excited for you guys to see that as well. Once we have access to our logs, we need to learn how to read them. But before that, we need to understand the high level architecture of the update stack. As shown in the diagram, we have different components that all work together to provide you with a seamless update experience. We have Intune as our management tool, where admins like you or me can configure policies to cater to your organization's need. Intune can communicate to our cloud service via the Graph API, and the cloud service is what connects to DCAT, which also stands for Delivery Catalog. DCAT is where our updates are published and where the client scans to get the update. That's where the Windows client component comes in. Now, within the Windows client component, we have our policy reader, we have the UX, which represents your update notifications such as DOS, dialogues, as well as the settings page. We have USO, which stands for Update Stack Orchestrator, and we have Woo, Windows Update, as well as our trusted installer called CBS. These logs can be split into three parts, and we'll be looking at them as such. We have USO, which tells us where the update is facing problems. We have UX, which will tell us if you're facing a reboot or notification related issue. And then finally, we have Woo logs, which tells us why a particular update is causing problems. Now, USO also again stands for Update Stack Orchestrator, and it is known as the brain of the update stack. It decides what happens when and is the link between the update UX that you see and the Woo client, which communicates to DCAT. USO is vital for helping your machine to conduct its update operations in the most effective and productive way. Think of it as a traffic warden guiding cars to reduce traffic, but in this case, it'll be handling your device updates. For USO, we'll be looking at the Mo USO code worker logs, which we will search through as the following. We will be checking for non-zero H results for four items, namely star scan star, star download star, star install star, and star commit star. These indicate which part of the update process that the specific update is failing in. The reason we do this sequential process is so we can walk through the update operations that USO is responsible for and check if there is a problem in any of them. Note down the update ID for any non-zero age results that you encounter because that will be super helpful later on. Next, we will be looking at the UX, as in the user experience part. And USO also comes into play here as it triggers the UX broker to take action to show notifications and toasts as explained earlier. So, why is the UX so important? Because it helps us answer the question, what did my end user see? And there are three different UX logs that we're going to be taking a look at. The first one is More UX Core Worker, which involves policies and reboot timing. The second one is Update UX, which involves settings page issues. Third one being More Notification UX, which involves notification issues. So the question arises, did the reboot and notifications happen when they were supposed to? To answer this, we'll be searching for the following five items. Firstly, to check for configured policy, we'll search for are any UX policy set. Secondly, we'll search for did it successfully scan, download, and install? If reboot required is found for that update, then it successfully made it to reboot pending. Thirdly, we'll search for when was the reboot supposed to happen. To do this, we'll check for reboot scheduled. Fourthly, we'll be looking for did it actually happen? And to see this, we'll be searching for defer restart and if that is set to true. And lastly, did the user actually see a notification? To look at that, we'll be searching for display notification and if that is set to true. Next, we're going to show you how this will look in practice via a pre-recorded demo, which will show you what happens when the notify to install policy is invoked and the user has interacted with the notification.
Hey everyone, so we're going to start out this demo by going to GP and confirming that our notify to install policies have been configured correctly. And then once we confirm that, we go to the setting page to check and to make sure that our update is actually pending install. We go to the Windows Insider program to make sure that we're enrolled. After that, we go to our configured update policies to confirm that, hey, the update policy is actually administered. After that, we go to our logs and we go to program data, to USO shared, to logs, and then to user and system. So basically what we want to do in this particular case is open two log files, mainly More USO Core Worker and More UX Core Worker logs. In this particular case, we're opening the More UX Core Worker logs first, and then we'll also be opening the More USO Core Worker logs. As you can see, the More UX Core Worker logs are open now. Then we go to More USO Core Worker. And within More USO Core Worker, we control F for notify to install. Basically, what we're trying to see if is notify to install actually set to true. That means is this policy actually being configured correctly and being set to true, which as you can see in this particular case, it actually is. That means the user will be notified before install and they will be required to approve that. Next, we go to the More UX Core Worker logs where we search for install. And what our main goal for this is to check and to verify that, hey, the user hasn't approved the notification and the install, which is why the install won't happen. And as you can see, it says when we look for this is install need user agreement. And as you can see in this particular case, the install need user agreement has been set to false, which would mean that the user hasn't approved it and the install won't be going through in this particular case as well. Again, to highlight that as well. After that, we go to our third set of logs, and those are the More Notification UX logs. Here again, we'll be searching for install, and what we're trying to do in this particular case is to verify that the install notification was actually displayed in the form of install notify needed. And as you can see, it was actually displayed because it has been set to true. And to double verify that, we look at the notification UX launched. and that also shows us that the notification was actually displayed to the user. The user did not interact with it, and what that will lead to is that um, the install would not happen, and that's what the policy basically dictates in this particular case.
So if you already know where the update went wrong, you can skip all this and start at the vlogs as well as the Windows Update error code list. To look at vlogs, it'll help us answer the question, what do I do once I know where the problem is? And the vlogs can help you do this. So once you've identified the problematic update ID or error code, we'll search for that value in the vlogs. Here, we'll be able to identify the problematic event in more detail along with its cause. As shown in the example on the screen, I searched for the error code 80073D02, which told me that the error I faced is an install Apex package failure error. The vlogs are so important because oftentimes errors that you see are transient, meaning that they come from different layers in the update stack. And believe it or not, even updates can be very complex at times. So, how can you fix this? Firstly, you can reference our error code list along with the suggested remediations. If the error you found is not in that list and there's a download slash install error, let the device retry. Oftentimes, retrying can fix the issue itself. If that doesn't work, please file a feedback hub bug and in the description, attach the logging files you viewed along with error code that you have found. This will allow our engineers to take a look at your problem and potentially it could be a bug in the code. Thank you so much for watching and please stay tuned for what's next.
We hope you feel more confident with your update issues. If you have any questions, leave a comment or reach out via Microsoft support, and we'll be happy to help you. Thanks.